In today's lesson, we are going to be looking at correlation types. So we're still looking at two variable analysis. So we're still looking at comparing two variables together to see if there's a relationship or a correlation. But we're going to look at specific correlation types that could come up, or if we have a specific correlation between two variables. So as a warm-up, in the course content, if you look at this PDF and click on the image below, it will take you to a video. And what this video is going to show you is how correlation does not imply causation by looking at what the variables are. So they're going to look at different variables. They're going to look at basically creating a linear regression or some type of regression to see if there's a correlation, and they will find that there is a correlation between the two variables. Like, so for example, I believe one of them is ice cream sales and drownings. So there is a positive correlation between them, that as drownings increase, or as ice cream sales increase, drownings also increase. So does that mean that the more ice cream we sell, the more kids drown? Right? Does ice cream cause drownings? Right? From hearing that statement, we know that's not true. It's almost, using common sense, it's ridiculous that ice cream would cause drownings, unless you fell into a giant vat of ice cream. But just because there's a correlation and the data says there is a relationship, doesn't necessarily mean that one causes the other. So what we're going to look at is different scenarios that could come up if there is a correlation. So the types of correlations are important because there is a danger to saying that one variable causes the other. Right? If for every correlation it meant causation, then that would be a dangerous precedent, because that would mean we could easily jump to conclusions without considering other factors or other things at play. So there are four types of relationships that we could have when a correlation is present. The first one is a typical one, the cause and effect correlation. So cause and effect correlation is that some correlations have enough evidence of a cause and effect relationship. And basically it means that one variable causes the other. Right? So for example, smoking causes cancer. There's enough correlation between different variables and different factors where we can conclude that smoking causes cancer. Right? You look at all the carcinogens that are in cigarettes and other smoking devices, and we can look at all those factors and the rates of cancer in individuals who smoke. We can say that there is a cause and effect between that. A more simple one would be the height that a ball is dropped from and the height that it bounces. There is a cause and effect there. The higher the height the ball is dropped from, the higher it will bounce. Again, that's a very simple cause and effect relationship there. Another one is a common cause. So this is similar to the ice cream sales and drowning. This is where two variables have a correlation that is caused by a third or outside factor. So there's another variable at play that we're not taking into account. If you click on in the PDF this image below, you'll see a small story about ice cream again. It seems to be that ice cream is a major killer. There's a video talking about a correlation between ice cream sales and polio. So in the past, they found that as ice cream sales increased, so did the rate of polio, or the occurrence of polio, among kids. So some people were making the claim that ice cream is causing polio. Again, common sense states that's completely ridiculous, but there is a correlation there. We do see that there is a correlation between those two variables. Same with ice cream sales and drownings. There is a correlation, a positive correlation between those variables. So there has to be something else at play, because again, we know that those things cannot be caused by ice cream sales or by ice cream in general. So the third, or the outside factor, one is temperature. Right? When do you eat ice cream more? Well, in the summer. right? What do you do in the summer, right? One pastime or hobby is swimming, right? You're going to swim more in the summer, or more people are swimming in the summer. So it makes sense that drownings also increase, right? Because more people are swimming, more people are drowning. At the same time as ice cream sales are going up because of the warmer temperatures. The same thing can be said for polio, right? A lot more interactions, right? Kids are interacting with each other outside, right? The higher temperatures kind of like breeds bacteria and stuff like that. So there are, in common cause relationships or correlations, even though there's a correlation between the two variables, it is usually caused by an outside or a third factor that we haven't looked at. Reverse cause and effect. So this is where your independent and dependent variables are switched. So it's not actually your independent variable that's causing the dependent to happen or affecting the dependent. It's the other way around. Again, if you click on the video in the PDF, it talks about a story or a study on using a nightlight and nearsightedness in children. So the study was looking at, does using a nightlight cause nearsightedness in children? And they found that there was a correlation between it. So if that was the case, well, we have to prevent the use of nightlights because we don't want nearsightedness in children, right? We'd prefer if they didn't have to buy glasses or contacts or things like that. However, when they looked at it further, it wasn't that nightlights were causing nearsightedness, because nearsightedness is a genetic trait passed down from parents. So what happens is it's actually the parents, their nearsightedness was causing them to use a nightlight. So because they were nearsighted, they used a nightlight, and not because using the nightlight caused nearsightedness. So again, this is something you have to think about, possibly with further investigation into your actual variables or your actual data, or maybe even other variables around it or surrounding it that would cause you to think about reversing your cause and effect. So reversing which variable causes the other. And then lastly, accidental correlation. So sometimes correlations between variables have nothing to do with each other. Or there's correlations between variables that have nothing to do with each other. They're not related. So there isn't a cause and effect there. There is a possibility that there is a common cause between them, but sometimes it's just kind of coincidence, just random, that there is a correlation at all. And if you take a look at the following website, again in the PDF, if you click the link, it shows overlaps of variables that have nothing to do with each other. So if we were to look for a correlation, we would find a positive, or we would find a strong correlation between these variables. However, when you look at what they represent, you would argue that there is nothing to do between them. There might be a common cause, or you might be able to think of a common cause or brainstorm one, but chances are there is no relationship and it's just an accidental correlation. So one of those examples is the divorce rate in Maine correlates to the per capita consumption of margarine. So looking at this, could we argue that the amount of margarine consumed influences the divorce rate? Or could we make the assumption or the statement that the divorce rate causes the amount of, or affects the amount of margarine consumed, right? So like a go-to, if you get divorced, you go and instantly start eating margarine, right? Not going to be the case, right? Generally speaking, we would say that these two variables have nothing to do with each other. You could find a common cause, which maybe is when you divorce, you have two different households right now, right? Assuming you still live in the state of Maine, you have two different households, so each person is now buying their own individual margarine, so that would influence the consumption, basically saying there's more people buying margarine now, right? That could be a common cause, right? Just looking at the number of number of individuals buying the margarine, right, or the number of households purchasing it. But again, generally speaking, there's probably not a correlation between these two. So even though we do see a correlation, doesn't necessarily mean that there is one. Is a relationship. All the relationships that we've previously mentioned are assumed to have a correlation or a strong correlation or some form of correlation. And generally speaking, if the correlation is weak, again remember less than 0.33, then there's a chance that the correlation may be accidental. Right? Again, there may not be an actual correlation or relationship between them. So again, short lesson, but the idea is to understand that not all correlations, or that correlation doesn't necessarily mean causation. So we do need to be careful about making a blanket statement that the X variable or the independent variable causes the dependent variable. We want to be careful of that until we actually look at our variables, look at the correlation, and think about, is there anything else, or is there another type of correlation that we actually have aside from cause and effect?